So I want to step back a bit now and talk about how JAX works, because it's interesting to use a powerful black box like this, but I think it's even more fun if you know what's going on under the hood. And the gist of how JAX works is that it traces Python functions. So just as a thought experiment, let's take a look at this function, f of x return x plus 2. What does this function do? You know, it may seem obvious, but Python is such a dynamic language that this function could literally do anything. You know, say if x is an instance of this EspressoMaker object that overloads the add function so that when you tell it the number of espressos you want, it'll SSH to your EspressoMaker and make those automatically. This is a little bit silly, but it just drives home the point that we don't really know what Python functions do unless we know exactly what's being passed to them. And JAX takes advantage of this Python dynamism in order to figure out what's going on in a function and to come up with a representation that can be transformed in the way that we saw earlier. So it does this by calling the function on what's called a tracer value. So an example of this is a shaped array tracer value. And you can see what happens here is that the add function not only returns a shaped array with the result, but also records the computation. This isn't exactly what's happening in the JAX code, but it's the basic gist of what's happening under the hood. So how does this work? So let's say you have a function like this that computes the base 2 log of a number x. How does JAX trace this and understand what's going on? Well, the first thing is all of JAX operations are based on operations in lax, which is this set of primitive operations that mirrors XLA. And now when we want to compute the log base 2 of some array, the first thing we do is put in